Now we're going to take a look at the second part of our trial, and that is developing a model. So to plan a statistical hypothesis test, you got to tell them what model you're using. All models require assumptions, so state the assumptions and check any corresponding conditions. For our case, most of the time, we're going to be looking at the normal model, especially right now. So because once I look at it, I should say, hey, I can use the normal model because all the conditions are satisfied. Or maybe I'm going to find out actually that I can't use the normal model. And if that's the case, I need to either stop, or I need to say I need to change my data, like get a larger sample. What's the issue with the way the sample was taken? Each test case we discuss in the book has a name that you should include in the report right now. We are just using test about proportions, which is called the one proportion z-test. So let's go ahead and develop a model for 3 different examples. The same 3 we started with before where we had the hypotheses. So the smoke detector case. Let's take a look at, this is where they went and looked at 400 randomly selected homes. So that looks like we hit the random sampling condition. Independence. There's no reason to presume one house affects the other in terms of owning a smoke detector. 10% condition. If there are more than 4,000 homes in the city, we're fine, which most cities have more than 4,000 homes, but not all. Success failure condition. Go ahead and calculate NP and calculate NQ and show that they're both greater than 10. In this case, they are. So the conditions are satisfied, so we can use the normal model to find a one proportion Z interval. Okay, so let's go ahead and create the model. So that's what we're going to do. We know that P is 0.90. That's P stands for the parameter for the population for the 90% for the nation. I'm going to calculate the standard deviation for the proportion, and that would be 0.9 times 0.1 divided by 400. That comes from P times Q divided by N, take the square root. So the name of my model is N 0.9, 0.015. So if I were to draw it, I would have 0.9 in the middle, and 68% would go from 0.885 to 0.915. 95% would go from 0.87 to 0.93, and 99.7% would go from 0.855 to 0.945. If you're drawing the curve, you really should say either show the percents or indicate in some way that each of those steps is one standard deviation. Okay, next example, I'm going to create the model for this one. Always check conditions and assumptions. Is this random? Well, we're going to assume it's sort of random. There's no reason to think one bag's any different than another. You could say, hey, it's a cluster sample, and you'd be right. But there's no reason to think this bag is not representative of all the M&Ms. Could be, maybe. You can always put your hedge in there if you need to. Are the colors independent of each other? I hope so. So that's checking independence. 10% condition. Yeah, 122 is definitely less than 10% of all M&Ms. Now I could say, well, M&Ms produced at a factory. I'm pretty sure they produce more than 1,000 M&Ms in a batch or factory or whatever level I'm looking at. Finally, the success failure condition, when I do N times P and N times Q, that should be little n on the bottom, they're both easily more than 10. So my conditions and assumptions we're going to assume we're good. So now I just have to name the model. I know P is 0.2. Going to calculate the standard deviation for the proportion using square root of P times Q divided by N. So I get 0.0362. I'm using a normal model as indicated by the N, which is 0.2 is the mean and 0.0362 is one standard deviation. If I draw the curve, 68% falls between 0.164 and 0.236. 95% falls between 0.128 and 0.272. And 99.7 goes from 0.091 up, an extra standard deviation up there, probably about 0.3. For some reason, this one chopped off the last standard deviation. Okay, the last model we're going to develop is for unfit teens. So let's first of all check our conditions and assumptions. 10% condition. 2205 should definitely be less than the 10% of the total population of adolescents. All right. Success failure condition. When I go n times p and n times q, easily those are, did I say less than? They have to be greater than 10. That's strange. I wonder if I did that on my other ones. So greater than 10, whoops, pen, greater than 10. And greater than 10. And this has to be, I bet you I got it from this 10% right here. All right, so we fixed that. Is it a random sample? Well, they said the researchers themselves believe that the sample was representative. So we're going to say, hey, it's good enough. And independence, there's no reason to assume that the results are dependent on each other. So we should be okay on conditions. Now let's go ahead and figure out the model. P is 0.30. It was given to us. Calculate the standard deviation for the proportion, 0.0098. So there's my model. And you can see here, 68% is between 0.29 and 0.31. 28%, 95% is between 0.28 and 0.32. And 99.7% is between 0.271 and 0.329.